Ohm's law. Most technicians and students are familiar with the triangle that helps us understand the relationship between volts, amps, and resistance. You've probably seen it, E over I times R, or maybe V over I times R. And you may have even heard of Watt's law, which is this one, P over V times I. Memorizing a formula doesn't necessarily help you understand a circuit. What we need to do is understand the relationship between these and how each one of these three things, or four things actually, affects a circuit so that when we're diagnosing an electrical problem, we have a better idea of what's going on. So in this video, we're going to cover voltage, amperage, resistance, and power. Now, we're not going to get into the different types of circuits where the laws or rules behind these change just a little bit. So we're not going to talk about series circuits, no parallel circuits, no series parallel circuits. We're just going to look at basic Ohm's law in simple circuits and how they relate to each other and how they can greatly affect each other depending on the circuit itself. So the goal in this video is to understand what these four things actually mean and, again, how they relate to each other. Okay, so let's dive into what these four things actually are in a circuit. So let's jump to my whiteboard here. And voltage, signified by the letter V, is electrical potential in a circuit. Or the push behind the circuit. And the way I relate this to my students is it's like us pushing a car. The more students we have, the higher the voltage would be, and the more or the quicker the vehicle is going to be moved. So think of voltage as the push or the electrical potential in a circuit. And hopefully that will help you understand it a little bit better. The second thing is current. Current is equivalent to amps. That is what it is, amps. And it is signified by a big letter A. Okay. Amperage is the rate of electrical charge flow. So how much electrical flow is there in a circuit? And that is the definition of amperage or current. Okay, the next thing we'll look at is resistance. Resistance is measured in ohms, OHMS, and is signified by the omega symbol. You'll see that a lot in automotive and other applications as well. And resistance is the opposition to current flow. So again, I relate this to, in the example of us pushing a vehicle, if we're pushing a vehicle uphill, as we're pushing, gravity is giving us resistance, as well as the weight of the vehicle, as well as the friction of the wheels against whatever surface they're on. That is the resistance to us pushing. So that is the resistance to current flow is a resistor or ohms. So it is resistance to current flow. Excuse my horrible handwriting. That's why I'm speaking it as well. And the last one is power, measured in watts. And it is the rate that electrical energy is being used in a circuit. Okay, so now we know the basics. We know the four measurements in a circuit: volts, amps, resistance, power. I'm going to clear out these annotations. There we go. And let's take a look at Ohm's law. So now that we understand the four main parts in a circuit that we're going to be measuring, let's take a look at Ohm's law. So I'm going to draw Ohm's law up here in the corner, hopefully. It's hard for me to judge. There we go. V over I times R. So V is voltage, I is the amperage, and R is resistance. And there's our Ohm's law triangle right up there, right up above me. So if we didn't know amperage, then we would know we need to divide the voltage by the resistance. If we didn't know resistance, we would divide the voltage by the amperage. And if we didn't know our voltage, we could just multiply our amperage times our resistance to get the missing figure. And in an automotive electrical circuits, this is used surprisingly more than you may think. All right, so we just need to know two known values to calculate the third. And Ohm's law will help us to calculate what we expect to see in the circuit before we ever actually measure the circuit. So let's look at an example. All right, what I'm going to do here is we're going to do, we'll have a 12-volt circuit with 3 ohms of resistance and 4 amps of current flow. Make it nice and simple. I'm not the best at math, so this is going to be really easy math for us, okay? So in this case, if we didn't know our amperage, and I probably should have done it like this, we would take our 12 volts, divide it by the 3 ohms, and then we know we should expect 4 amps of current flow in that circuit. Pretty simple and easy to understand when you look at it this way. If we were to double our resistance, so let's go 12 volts, 6 ohms of resistance now, what would our amperage be in that circuit just by changing the resistance? So now our voltage divided by our resistance, we should have 2 amps of current flow in that circuit. And now hopefully you're starting to see the relationship here. So I doubled our resistance there. Let's drop the resistance way back and go 12 volts with 1 ohm of resistance. And what would we have for the amperage here? We're going to have 12 amps. So you can see as the resistance goes lower, the amperage or the current goes higher. If we have higher resistance, the current goes lower. So now you can kind of see the relationship between resistance and current. So Bill, how does this relate to an automobile? Let's say that the normal reading for this circuit should be what we have up top here. 12 volt circuit, 3 ohms of resistance in whatever component is in there, and 4 amps of current flow. Now, let me give you a big asterisk here. The manufacturer understands that there is resistance in wiring in every component in an electrical system, in the switches, in the relays, whatever. There is resistance in all of those things. So we're going to look at this 3 ohms. Let's just say that's the entire circuit resistance, okay, including the load in the circuit. So if we have a bad ground, that's going to be extra resistance that the current is going to have to flow to ground. And now instead of 4 amps of current flowing to make our headlights bright, our blower motor blow good, whatever else in the electrical system work, now we're limiting ourselves to only 2 amps, which will result in a dim bulb, a blower motor that's not blowing at all or is blowing very slowly. On the other hand, if now we have a partial short to ground before the load, then we would have our 1 ohm of resistance or even an internal short in a component in that circuit. Now we have a partial short to ground. A lot of current is going to flow. And this is the case where you could have a blown fuse because more current is flowing in the circuit than what it was designed to, resulting in a blown fuse. So in the previous example, we held voltage where it was, and we changed our resistance. So let's say that we don't have a resistance problem now. Let's say that we have a voltage problem, either too little voltage or too much voltage. How does that affect this circuit according to Ohm's law? All right, back to our original drawing here. We had 12 volts, 3 ohms of resistance, and that results in 4 amps of current flow. So let's say now that our voltage drops down to 10 volts. Our resistance is going to stay the same unless there's a short or an open or, some sort of corrosion or something in the circuit. Then the resistance will typically stay the same. So we'll say that it stays at 3 ohms. So what's that going to do with our amperage? At 10 volts, that's going to make it 3.33 amps. So again, the same result as a bad ground or high resistance in the circuit. It's going to drop our amperage. So as the voltage goes down, our amperage is also going to go down in the circuit. On the flip side of that, let's say we had 14 volts. Keep our resistance steady at 3. And what's that going to do with our amperage? Now we've got 4.67 amps. Enough to blow a fuse? No, probably not. If the circuit is normally designed to carry 4 amps, there's going to be a little wiggle room in there, and 0.67 amps isn't going to be enough to blow the fuse. But if the battery voltage gets crazy high, super high, then that may be enough to blow a fuse or multiple fuses, depending on, the rating of those circuits. So hopefully now you're seeing the relationship in volts and resistance to current flow. High resistance, low current flow. Low resistance equals high current flow. High voltage equals high current flow. And low voltage equals low current flow. So you're kind of seeing the results of all these together. So now that you kind of have a good baseline in Ohm's law, let's throw Watt's law in there and look at how power is affected in this circuit as well. So Watt's law, I'm going to go ahead and just clear out all my annotations. Watt's law looks like this. P over E times I, or power over voltage times amperage, basically, okay? So let's, again, we're gonna give our baseline of 12 volts, and we've got 4 amps in that circuit. So if we've got 12 volts, we've got 4 amps, then we should have 48 watts of power being used in that circuit. Now let's look and see how, as we change things, how that changes the wattage being used, the power consumption being used in this circuit. Because again, watts equals power. So to make our circuit complete, we're going to do 12 volts. Remember, we had 3 ohms of resistance, 4 amps of current, and 48 watts of power being consumed in this particular circuit. So now let's say that in our example of the voltage going from 12 to 10 volts, let's take a look at that and see how it affects things. So now we have 10 volts. So we know from the previous example that our wattage at 10 volts with a 3 ohm resistor was 3.33. amps. So now our power consumption should be roughly 33 watts of power being consumed here. All right, and let's go back to our 14 volt example. So, 14 volts. We had 4.67 amps. And that's going to make 65 watts. So 14 times 4.67. So a huge difference in power consumption in that circuit. You wouldn't expect it to jump that much, but it does. There's a lot of power consumption in that circuit. So voltage, current, resistance, and power are all related to each other. And so now you may be like, well, Bill, okay, you've covered Ohm's law. I understand the relationship between them, but what does this have to do with me working on vehicles every day? Well, the manufacturer already has in their service manual what you can expect to find in a circuit. Where this really comes into play, though, is when you are doing custom builds or you are building your own circuit in a vehicle, adding a custom accessory or something like that, knowing then what to expect so that you don't overload the circuit. That's where this really comes into play. And that's when you can calculate ahead of time what you should see in the circuit and then measure it to make sure that what you're expecting, what you know should be there, is actually there. And if it's not right, then you know, hey, I've got something else going on in the circuit that I need to diagnose, whether it's a component that's partially shorted, or I've got high resistance somewhere in the circuit. Now you have a better idea of what to expect in that circuit when it's operating normally or abnormally. Okay, let's check out an example from a modern hybrid or high voltage vehicle, or one that's got a high amp circuit in it. Let's talk about milliohms. Now, milliohms is very small resistances, okay? And just for the sake of this lesson, we're going to go, good Lord, hang on a minute. What am I doing? Okay, we're going to go with 0.01 ohms, which is 10 milliohms. Now, that is a small a. Milliohms means we're dealing with a very small resistance. Eventually, in a future video, we'll talk about mega ohms, which is a ton of resistance when we're measuring insulation in high voltage circuits. But for the sake of this video, today we're going to talk about milliohms and some concepts that are really going to blow your mind when it comes to high voltage circuits, and how just a small resistance, when we have high amperage, affects the circuit. So let's say that we have a 100 amp circuit and it has 10 milliamps of resistance in it. Now, using Ohm's law, remember, if we don't know our voltage, we just multiply the resistance times the amperage. And in this case, we are actually dropping 1 volt across this 10 milliamp resistance. That's wild. Okay. So and a tiny resistance matters when the current is high. That can totally affect the circuit. That can create a lot of heat, which can cause a fire in a hybrid or an EV vehicle. So when it comes to working on hybrid and electric vehicles, I did some training 2 weeks ago, and one of the things that they were really tough on was torquing the connections between the drive motor and the inverter, or the cables between the drive motor and the inverter and the cable that goes to the drive motor, making sure that those are torqued properly and that they have a nice snug fit. Because if they're not torqued properly, or just the grease from your fingers can give enough resistance that will create a drop of voltage and create heat that can cause a fire in those systems. So another thing we'll do in a future video is we will actually take a milliohm meter and we'll measure the resistance of different fuses, different rated fuses, and see that there is a variance in resistance depending on the rated amperage of that fuse. And we can take what little bit of voltage will be dropped across that resistance to help diagnose phantom drains or parasitic draws. It is a huge help when it comes to parasitic draw diagnostics. So we'll cover that in a future video, and I'll give you a really cool tip on how to do that if you don't already know how to do that. So our main takeaways today from this video is the relationship between volts, amps, resistance, and power, and how they relate to each other in a circuit, and how a change in voltage, a change in resistance can affect the amperage flow, the current flow, or the power output, or the power consumption in a circuit. We also touched on milliohms and how a very minuscule resistance can affect a high amperage circuit in a negative way. And I touched on mega ohms. We'll deal with it at a later video as well. So I really look forward to the future videos. I'm going to have a whole series on electrical system diagnosing that I really think y'all are going to love, and it will help you tremendously. But I wanted to start with the basics. I wanted to start with the Ohm's Law to give you a good baseline, a good foundation that we can build on as we go forward with this electrical diagnostic series. So take care, everybody. Please like, subscribe. Drop in comments, your thoughts about this video. Too simple? Do you have questions? Are you left questioning? Are you left with more questions after watching this? Thank y'all so much for watching. I will see you next time. Until then, I am Bill, and this was Bill Teaches Automotive Technology. God bless. I'm out.